Okay, doing one more example here. I guess you could say sort of a non-example because it's going to just be here to show you that this generalized power rule doesn't always work, and I think that's kind of important to mention. You know, the generalized power rule is kind of this really neat rule that integrates a lot of complicated functions, but doesn't always work. And in fact, this is a good example of an integral, which we do have a formula for, but it's sort of a specialized formula. But you might think that the generalized power rule works just glancing at it. Okay, so using the ideas that we found that we've kind of started with. Remember, the idea is we call something u, we compute du, and then we try to make a replacement to get an integral that can be written as u to the power n du. So basically, in the examples that we've tried in the past, what we probably would call u is 1 plus x squared. Okay, because this big function we're integrating consists of x squared times the square root of a bigger thing, 1 plus x squared. So usually we take the biggest thing that's being raised to a power, or the biggest thing that's inside of a root, and we call that u. Okay, so if that's u, du is going to be, and remember du is the derivative of u, okay, which is 2x, right? Derivative of 1 plus x squared is 2x. So du is du dx times dx. Okay. Well, let's try making the replacement here. Okay, well, we've got the square root of 1 plus x squared. That's nice. Okay, and then we've got x squared dx. Okay, just move the x squared over and wrote it as the second factor. Well, if you look at this, you can see we're kind of in trouble. Okay, this is, of course, the square root of u. Okay, we can make that replacement. But we need 2x dx. And we've got x squared dx. Okay. Well, you might say, oh, what am I missing here? I'm missing a 2, right? Well, that's easy enough to fix. We can multiply by 2 and then multiply by a half. Actually, I'll write it this way. All right, so I've got my x squared dx, but I'm going to do two things which cancel. I'm going to multiply by a half and then multiply by 2. Okay. So if we do that, we can factor out the 1/2, which we don't really need, and leave that 2 in front of the rest of the term for du. Okay, but we're still in a little bit of a problem here because we have 2x squared dx. Now we need just 2x dx. Okay, so you might say, well, what if we take one of these x's and just kind of move it to the side, and then we have 2x dx, right? Okay, well, that's fine, and that certainly works, and we can definitely call this du. We're right here now. We get the integral of the square root of u times x times du. Okay, but see, here's the thing. There's no rule that tells us what to do if we still have an x here. The only way this rule works is if we can get rid of all of the x's in dx and replace them with nothing but u's and du. Okay, it has to be a complete conversion. Because really, when you see x here, there is some relationship between u and x, and we can't integrate this simply if we have this, complicated second variable here that depends on u in some way. So, there's really nothing we can do here. And the problem is, if x was just if it was a constant, if this was a number like 5, we could factor it out. But you can't factor variables outside of the integral sign. You can factor constants only. If you have a constant factor, you can bring it out, just like we did with the 1/2. So we're kind of stuck here. I mean, what do we do with that x? Well, the answer is we can't do anything. There's no place to put it, and it doesn't seem like there's another substitution we could try where somehow this problem would be eliminated. You could certainly try making another substitution. Maybe just call u just x squared and see what happens. But you're going to pretty much run into this issue no matter what substitution you try. There's something you just can't get rid of. And again, the way this, we realize this is just, when we tried to find du, or tried to replace that last part with du, we had the wrong power of x here. We wanted just x, or 2x would be better, but we have an x squared, and we can't really get rid of that extra factor of x. No matter what we try, it's still there. So what do we do? Well, the bad news is, we can't use the generalized power rule here. This is pretty much, not leading anywhere. So there are other rules of integration, of course, and there is one that will apply for integrating a function like this, but that's something we haven't covered yet. So generalized power rule is nice, but again, it's not a miracle formula. There are certain integrals that it just can't do.